Welcome to Relay Chain, a podcast produced by Parity Technologies where we discuss all things Substrate, Polkadot, and Web3. Today we have Ingo and Timo from KILT Protocol. Do you guys want to introduce yourselves and KILT? Ingo, you can go first.
Yeah. Hi, I'm Ingo. I'm a computer scientist. I studied computer science in Berlin. Went into the industry in the 90s of the last centuries. Actually, was working a lot in publishing. The last job I had was actually CTO of Burda, Burda is one of the biggest publishers in Germany. And I came on blockchain in 2016 actually, noticing that this is going to develop something which we could call Web 3.0. And I went to the group board of Burda and said, okay, as a publisher, you have not been really successful, or we have not been really successful in the Web 2.0, and that the reason for that could be probably that we just waited for the technology to finish and then adopted our old business model, which was printing newspapers to the new technology and make newspapers in the internet. And if something new comes up like the Web 3.0, I think it's a new chance for us to get involved there pretty early. And they said, okay, we should be involved there pretty early, and we'll set up a company. If you like, you can be the CEO. And this is how I got to KILT.
And Timo?
My name is Timo. My background is also as a computer scientist. I was mainly a web developer, full stack, and did web applications, also for Burda, where I met Ingo. Ingo then introduced me to blockchain and sparked an interest there. And when we were talking a lot about KILT, we formed this, I guess, together. So I was one of the first on this company. Yeah, right now I'm the technical lead, and I was building the SDK, the first testnet, our demo client, simple services.
Great. So when we started, before we even started recording here, I made an error and asked you about identity, and which is the first thing that came to mind when I saw your website, or your project. But you immediately said it's much bigger than identity. Identity is just a use case of your protocol. So can you talk about your protocol from a very generic standpoint and what you're trying to build?
Yes. When you look at actually we came from the idea that we need something like identity on the protocol level. But coming from protocol level, you see pretty early actually that identity is something which cannot really be solved or should not be solved on the protocol level, and people who are doing that are actually building applications on protocol level. This is actually not what we wanted to do. So when we started the company, we first built up a team of computer scientists, mathematicians, philosophers, and legal people, and so all kinds of people, and started to think about the implications of identity. And the first thing which came out is that it's actually not a good idea to think about identity, because when I say I'm Ingo, then this is obviously a part of my identity, but if the glass in front of me says that it's half full, then it's obviously not a part of its identity. So what we're talking about is actually attributes of things and attributes of people and attributes of organizations. And we need, when you go to protocol level, you always have to take a step back, because you have to build something which is useful for as many use cases as possible. This is why we came to the notion that actually we're not talking about identity, we're talking about attributes of entities. And the way to do that, if you see the standardization processes around you, like what the W3C is doing with verifiable credentials, is the solution on protocol level should be, in our opinion, that claiming entities should be able to claim attributes, and that attesting entities should be able to certify those attributes and then put them in the possession of the claimer. This is actually what we do in KILT Protocol. So you can use that for many use cases, and identity is definitely one of them.
So before talking about the future, how does this work now, both offline and online? So if I want to make a claim about something in the outside world, offline, how would this process happen? And then same online, like if I want to say, this is my account, I want to log in, how are those handled now, and how will it change with KILT?
Right now we have different approaches to certification, SSO logins, with different methods. Google Auth, we have Open Auth, different ways of logging into things. We have different certification systems. What we are trying to achieve is to have a general approach to claiming something and getting an attestation which is verifiable in the end. And how we do this is we are thinking about the entity who is doing a claim. So it's starting from this point of view, right? The claimer, the entity who wants to have something attested, starts first always. You don't get something, you start and say, I'm a user of this platform, I have a login, and first this is maybe a false claim. But then you go to a website, for example, and then show maybe your other credentials, show something they need to sign you up. And you will get to this claim that you are a user of this platform, and an attestation, a certification in the end, which says, yes, you do have this access. The websites can verify this claim because we have a schema inside, and the schema might be standardized for at least this website, maybe more. Maybe you want to build a more open SSO, so many websites could come together and find a schema which works for everyone. So I can claim I'm a user of Google, for example, and they will just give you an attestation for that, and everyone who is okay with such a login can accept this too. So yeah, I'm claiming something, and I go somewhere to get an attestation, and they give me this attestation. This all works first on a peer-to-peer basis, not only over peer-to-peer networks, could be Bluetooth, Wi-Fi, QR codes, email, WhatsApp, whatever. We're only flagging the attestation on the chain.
And this is KILT, this is not...
Yeah, this is...
I'm trying to distinguish how it worked before, just so we have some foundation for moving forward.
So when you look at how the Web 2.0, when you differentiate the Web 2.0 and the Web 3.0, which is where we were part of, the basic difference is that in the Web 2.0 you go to a service and you give them a username and a password, and if the username isn't taken yet and the password is long enough, then you will be signed in. And this actually generates three big problems. The first problem is that it's actually a shared secret, right? So you know the username and the password, and the service knows the username and the password, and that's not a nice feeling. A second problem is that if this service is somehow successful, they will accumulate a lot of usernames and passwords, and as they do this, they become a very good target for hackers, actually, because the hackers only have to break into the system once and they get millions and millions of usernames and password combinations. And the third problem, which generates, is a more economic one. If a service is really successful, then this service automatically in the Internet 2.0 becomes a monopoly. So just try to imagine you have a better idea for an Airbnb, and you go to your venture capitalist and you say, okay, I have a better idea for an Airbnb. The venture capitalist will probably say, okay, we won't give you money because there's already Airbnb and they have their own market. How will you get across them? So actually this is hindering innovation, and this is a huge problem. And what we try to establish is a technological foundation where services can decide not to use the username and login procedure, but to use a credential procedure. So I claim that I'm a user, as Timo said, of this platform, and the platform says, okay, I trust you, and this is the credential, and the credential goes into the possession of the claimer, so it is my data. And I choose who I show this data to. And the attester actually just gave me the attestation. So of course the attester can keep whatever I told the attester about me. But this is subject to, in the end, GDPR, right? So he can only take this if he handles the data in a way that is appropriate.
But that's only in Europe, also.
That's only in Europe, but I think GDPR is something which maybe the first thing in the last 100 years which comes from Europe and will spread the world, actually. So.
Yeah, I mean, back to your question, how it is now. This is difficult to answer for us because we are not targeting one use case, right? We are targeting a lot of use cases. So how is it done now? It's completely different for multiple use cases. You can make basic auth. You maybe you have username, password with a login and sign up. For claims like in logistics, where I say this product was always cold while going through all these stations. This is different. This is handled completely differently, right? I mean, some have trackers, some have some ideas, some scans QR codes, some have a central server who does it. And we would, our technology helps that you always just have this claim and attestation, right? I mean, the product claims I was cold and everyone at the station just attested, this was right. So it's hard to say how it was now and how we solve one use case now, because we are very broad in this sector.
Yeah, it's very generic. But I guess if we focus just on online things like sign-ins, how easy is it to fake an authentication? Yeah,
I mean, right now you have different attack vectors, right? First you have these databases which are hacked, where people might either get username and plain text password in the worst case, or they have these lists of hashes and maybe they're not salted. And then you just have to brute force it a little bit or have a rainbow table or something and figure this out. Or, I mean, most people are using just weak passwords, right? So you just brute force it. I mean, this is also possible. People leak passwords. Maybe there's another browser extension which just listens to password input fields and just scans it.
Using the same password is another.
Using the same password is a thing a lot of people do. There are different attack vectors, right now when you're just talking about logins and sign-up procedures.
So how does KILT approach this? Like, I'm assuming there's some private key where you hold all of the information, but what happens if you lose this key, or what happens if this key gets leaked? Are you kind of exposed everywhere, or how do you recover from that?
For the recovering of a key, we don't have an exact proposition right now. All the attestations are revocable on chain, so you might have to go and revoke everything which was done for your ID. Maybe you have to publish your public identity to like a list where you say, okay, this is not working anymore, right? I mean, if it was stolen and you still have access, you can put it on a list maybe.
But there's many things actually you shouldn't solve on the protocol level. So, for example, it's a good question. So, what happens if I have my wallet full of credentials and I lose the key? This is something which will be handled on the application level, actually, because we're not building the wallet. we're just building the infrastructure so that other people can build the wallet. And of course, that's another question: is how do I log into my wallet? So how can I make it secure? So will I use my fingerprint or iris scan, or will I? So this is all application level. We don't really, we can't say how to do that, because many people will, or for many use cases, you will have different levels of security and needs of security. So if we propose you have to do this and this and this way, that would be wrong, right? So what we do is we just give the infrastructure for building the credentials, for receiving the credentials. But in the end, if you store your credential in your wallet and then you lose your wallet, or if you store your credential in a maybe somehow sharded or encrypted way on a central service which will pop up, or if you just put it on Dropbox, we don't know. So, and we can't decide, and we shouldn't decide actually, to become as open as possible.
Yeah, I mean, what we hope is that the users will mostly manage this by themselves, right? Or use services which are not meant to hold a single honeypot of all the claims and credentials of everyone, right? So when we are talking with other Meshblend partners, we will focus on that, so that it's distributed, easy accessible by the user, but also secure. Yeah.
So what kind of interface does this protocol expose?
We have basically our substrate-based runtime, right? So this is a node running which handles our so-called C types, which are our data types, our shared schema, so to speak. Maybe we'll speak about that later again. This has to do with that we want similar use cases to use the same schema, so that app developers can just attend to just a few schemas instead of every schema from every company coming up with like a coupon or something. We handle the attestations, so revocation of attestations, right, and also flagging of attestation because we want to use it for incentivization, and also for our for one of our trust mechanisms, which is more like a top-down hierarchy, where you can give other users the right to attest in your name, right? So this is our node. This is a distributed software, right? And then we have defined different kind of objects definitions based on JSON schema and other technologies, so everyone speaks the same language, right? So a claim always looks the same, and an attestation object looks the same, and you can send this to each other, right? For that to work, we built an SDK in JavaScript and TypeScript. I mean, it's TypeScript compiled to JavaScript. And this handles all these objects. You can either use it with the simple objects, just like the bare-bone protocol, or you can use all our helper functions and our classes and initiate them with your data and use it like this.
Yeah, I asked because we're talking about the application so generic. So for application developers, what do they see when they're interacting with KILT?
Actually, what they see is a JavaScript SDK, right?
Yeah.
And I think this is, and we did this on purpose. We come from industry, and we know that adoption is getting some track is the most important things. One of the most important things to blockchain protocols. Actually, we've seen a lot of things which really don't get any traction because they are too complicated and are not adopted by industry because there's just too little developers who are skilled to do blockchain protocols. So what we wanted to deliver is something which is so easy to use that a normal web developer could be successful in building applications on top of that, and that the web developer doesn't need to have a degree in mathematics, and that the web developer doesn't need to know basically how blockchain works. So this was our starting point. And so what we built is a very simple to use a JavaScript SDK, and on top of that we built a demo client which actually represents all the functionality that the KILT protocol has, with no particular use case, just to play around. But developers can take this apart and use parts of that and reuse parts of that for their development, so that they don't miss out on anything and stuff like that. So it makes it really easy for a developer to be successful and rapid prototype something. And I think this is not unique, but this is not usual in the blockchain world. But as we see a lot of industrial use cases, actually, we want to enable those people to be successful very easily.
Yeah, and some recent conversations about consensus, I feel like in the greater blockchain space, consensus always comes up as being defined by something about the blockchain itself. But the traditional definition of consensus is actually making a network of computers appear as a single computer. And so kind of my vision for some of these developer tooling systems is that an application developer might not even know that they're using blockchain. They just say, I want to launch on this kind of platform, and this is the interface that I have.
That's completely right.
I think that's a little ways away, but that's what we're going for. So I know in KILT you have these actors, the attesters, the verifiers, and the claimers. Can you talk about these roles, or did I miss some if there are more? what is each one trying to do?
Yeah, that's no, you didn't miss one. that's the real roles. So the claimer basically is the entity which claims an attribute. The attester is the trusted entity which certifies that attribute, and the verifier is the entity which receives the certified attribute from the claimer and trusts the trusted entity so that it can act in the way that the claimer actually wants that. So that's the basic idea behind that. There's one more idea. The attester is the one who does the certification. Doing a certification is always work. So when I lose my university diploma and I go back to the Technical University of Berlin and say I lost it but I need it, so please can you reprint it for me, they will charge me like 50 euros because they have to go down somewhere and look in a database and print it and hand it over to me. So this is work. So attestation is always work. If it's no work, then it's completely useless because then the attestation is worthless. So we think that attesters have to be rewarded for doing work, and we want the claimers to pay for that. So just when I go to the university and want my diploma again, I have to pay. This is a normal case, and this is why we call the whole thing a trust market, because the attester has the trust of a lot of verifiers in the best case. So the TU Berlin has a lot of trust with employers, obviously. So when I go with my university diploma, I will get more money than without. So and thousands and hundred thousands of employers worldwide will trust this certificate they can give. So it's something. It's worth something to attest that. So we want to build up a market, a business model for people or for organizations which already have trust, to market this trust to claimers, because claimers want their certifications or their certificates, and they go to those specific attesters because they have a lot of trust with the verifiers. That's the basic idea of a trust market. And we have some really cute examples already from projects we work in, where we found attesters they found us basically, which have a lot of trust out there in the population, but never had an idea how to monetize this trust. And with KILT, the first time they have the possibility to charge organizations for their certificates, which is really cool. So I think this is a market which works, and I think this is another adoption thing. Industry only starts adopting technology if they have a business case. This is something we noticed over the last 20 years. So if we go out and promote KILT, we always go to those people who actually have a chance to earn money that they didn't earn before with the system, and this is what makes it interesting, and this is how we will grow adoption.
So can you give some examples of who would be an attester?
Yeah, so I have a very cute one, which is the project is about a distributed registry for food ingredients, and we have attesters involved there, and those attesters are companies or organizations or associations which have some trust in the population. For example, they have a lot of trust with allergics, or they have a lot of trust with vegan regions, or they have a lot of trust with vegetarians because they are the vegetarian organization or whatever. And they build up this trust for quite a while, and so the population will trust them. But how do they monetize that trust? Probably not with setting up a website and doing some Google advertisements on that. So what they can do now with KILT is that they go to the food producers, the big ones basically, and tell them, okay, we have the knowledge to certify that there's definitely no hazelnut in this product. If you want us, we can test it. Of course, there needs to be a test. We can test it, and then we can certify that for you. And we put this on the KILT blockchain. And then we have publishers in this project, and those publishers run food recipe sites like and apps. So what do I cook tonight and stuff like that. And they build filters where the user can actually say, I'm allergic against hazelnuts and my wife is allergic against apples, and I actually want to be a little bit more healthy, so please do only low-fat stuff for me. And then we both decided that we don't want to eat too much sugar anymore and stuff like that. So you can put a lot of filters in there. And those sites will then, when they build recipes up from food ingredients, they will check the food ingredients against the KILT data and against the KILT blockchain. And if they have if they don't have certificates by those trusted organizations, like the vegan organization or the allergic organization or the whatever organization, they will not show those things if they don't have the certificates. So there's a pressure on the food producers to get the certificates from from those certifying entities, which are mostly common good organizations, so they're non-profit organizations, and those non-profit organizations will start to have a business model with that. So here you see how far it is actually from identity. Really.
Yeah. So if I can try to repeat what you said to make sure I understand it, this doesn't change the point of trust. You're still trusting this attester,
exactly.
But it changes the forgery market. So, like, the idea behind a trademark is that you can trust that what you're getting is legitimate. Like, if my computer says Dell on it, Dell has a trademark, and so I know my computer came from Dell. But that costs a lot of money in, say, legal or research teams to go find companies who are putting your stamp on their thing without your approval. And so by putting this on chain, you can just cut out all the forgery. If it says it came from this organization, then you know it came from this organization. And it cuts out all of the impersonation or forgery risks.
Yeah, it also produces a lot of more openness, actually, because when I have a food ingredient or a fruit like a chocolate, and this chocolate is then the chocolate is the claimer in our case, right? So the chocolate actually collects certificates. So I'm a low-fat chocolate, I'm a vegan chocolate, I'm a whatever chocolate. This information is then published, right? So because it is somehow it's there on the blockchain, and it's not really on the blockchain; it's hashed on the blockchain. But the food itself could choose to publish all this information about itself, and so what it brings together a lot of databases which actually exist today. So a lot of information about food ingredients already exists today in the world. But those things are held in different databases and they're never collected with the chocolate itself. So this is what we actually produce. So we produce more data, more accessible data for the population in this case.
So for these attesters, how do you trust them? So it seems like if we kind of focus on the identity application, if I'm an identity thief, trying to become an attester seems like the best thing possible. How do you prevent that from happening?
You can be an attester. You can attest me anything. You can attest me that I have a driver's license, but probably no verifier out there in the world will accept your attestation. So actually, you don't gain the trust in the system. You have to have, as you said before, you have to have the trust before. So we're building business models. We enable business models for people who already have trust. So the trust is generated outside the system. It's just transported to the system.
Okay.
Yeah.
That makes more sense. So if we go over to the tech side, you've been building on Substrate. Can you talk about, I guess you're a few years old, you started in 2016, right? What did you start with, and then how did you end up with your current tech stack?
First we were doing a lot of research, right? In the beginning there was no technology involved per se. We were more looking at our ideas of incentivization, standardization. We were thinking about, we want different application developers to use the same schema. Then we were looking into credentials, how can we do them? We wanted to hide data. We wanted to have different methods of having like trust chains. So you might trust an association, but you will get the attest, I guess, from some employee of this association. So there needs to be a connection there, for example. So we were going into a lot of different directions and talking to a lot of different people. And then when we decided to do the first prototype or testnet, we were mainly thinking about Ethereum to make it, just to make a prototype. But then we met you guys here at Parity, and we were talking about Substrate. And since we had all these concepts in our minds about how we maybe do incentivization, where we would need to incentivize people another way, and we always disliked that a user has to handle different type of coins, because we are also always very focused on use cases and making it work nicely. We wanted to do our own thing, right? But I mean, building your own blockchain and trying to establish this is not that easy, right? So Substrate really bridged the gap for us here, with the potential of becoming maybe a Parity or Polkadot, with the technology where we are fully modular and can just focus right now on runtime to just develop like our, so to speak, our smart contracts, but already be on a tech stack which we could potentially really use later on to build the mainnet on if everything works out. This was very exciting for us. So yeah, we built just the scratch a little bit on smart contracts, but then shifted very early to Substrate and to Rust, to the Wasm runtime. And yeah, we liked it so far very much.
Yeah, I think you were one of the first teams to build on it.
It was very early. It was in the first discussions we had. It was always like, yeah, documentation will be there in some weeks. So we started like really on the code basis and didn't have a lot to work with. But I mean, the modules were there. Sure, it was still very rough to be handled. Like the DX was not there yet, but I mean, we could build everything we wanted to build, right? So this was a big success.
And you mentioned in Polkadot, are you still hoping to integrate with that?
Yes, we are currently discussing to work closer together with the Web3 Foundation, which seems to be fruitful for both sides, I hope, because a credential system should be part actually of the ecosystem around Polkadot, which it makes sense for them, I would say. And for us, it would definitely make sense to be a parachain, because building up your own network of validators is a pain in the ass, and you can save a lot of time and money actually if you don't do that. So this is something which is ongoing and not decided yet, but we're moving closer together like every week, and so it's very probable that we will come to cooperation.
Yeah. So what are the like we were talking about the interface earlier, and you mentioned C types. How generic are those? Can you create your own, or do you have a library of C types to choose from?
You can create your own completely. So how it works is it's a JSON schema, and we have built a meta schema which just defines what you can describe in your C type. But this is very broad right now, so we wanted to keep experimentation open. And yeah, you can basically build every data structure you want with our JSON schema, which also includes like things like address, biometric stuff. You can nest C types. We're still working on if this is all in part of our incentivization mechanism, but yeah, you can do a lot of stuff with JSON schema.
Yeah, so you mentioned being able to conceal certain information. Have you looked into, or are you planning to implement some sort of zero-knowledge proof so that instead of revealing, say, the temperature history of this product, you can just say yes or no, it was below this temperature all the time?
We don't have it integrated yet, but we're definitely looking at the technology and talking to a lot of people around this. We actually having other partners who are also interested in that, and they are also talking to zero knowledge people. So yeah, I mean, we're looking into that direction. We are also looking into other signature schemes and Patterson commitment and stuff like this. Yeah, but right now what we have is a simple conceal of information where you just hash every attribute you have and build a root hash of that one. and just hide information, hide an attribute, just delete it. But you still have the hashes there, so you can build a root hash still from every attribute you got, and then only the hashes of the one you're not having, which works for most use cases very well.
Yeah, it seems like having a zero knowledge proof or something around a zero knowledge proof would increase a lot of the applications that can be built on this.
Mm-hmm.
And I know like we don't have any zero knowledge modules in Substrate yet. It's in our longer term roadmap, but I know there are people in the community that are interested in that technology and building on it. So I was wondering if you had done any work or how you see that playing out into your company's roadmap.
I mean, yeah, we are doing research, right, in this direction. We don't know yet how and if we will fully integrate it. I guess I can't say more about this, unfortunately, at the moment.
Yeah. So do you want to transition? We can talk a little bit about your plans for the future and what you want to do with KILT in the second stage.
Sure, Ingo.
Oh yes, definitely. Yeah. So actually, all the things that we're building now is just only the foundation for the second stage. Even though it turns out that even the first stage is obviously very interesting for a lot of industry partners right now, and it's fully functional and very nice that we build it. So I think this will bring us a lot of traction. But the second stage is actually the one that we're aiming at. The notion is that everybody knows DAOs, and DAOs are, well, we had one and it didn't really succeed, and this has a lot of reasons actually, and one of the reasons is that DAOs are definitely software, and software cannot really be checked by regulators, and companies actually need regulators around them, which sounds a little bit crazy, but it is the case. If I have a company and I invest money there or invest work there, actually I want to live in a regulated environment, which makes clear that I can pay some tax, but then I'm off the hook, that I'm not going to end up somewhere in prison and stuff like that. So actually we need, if we want virtual companies, we need to legalize them somehow, and we have to put them closer to the regulators. Regulators on the other side will never be able to check a software if the software is really correctly working and if the software can represent a virtualized company. So what we're aiming to build is actually a factory for virtualized companies. And it goes something like that. We will ask regulators to one time check the software stage 2 KILT and certify it or trust it that this will build new companies for them. And then if someone comes and wants to build a virtual company, this company is not going to be programmed but just configured on top of KILT. So there's some things, for example, you can put in there like everybody who wants to invest into the company needs to have a KYC AML check by this and this entity and stuff like that. And a company needs a tax number attached to it from a regulator, and before that it doesn't work. And we use a lot of technology stuff from the TCR world there, but it's not really TCR, so we're not curating a list of the best restaurants in Berlin. We would rather curate a list of persons who can then certify, because it's a certification system again, who can then certify which is the best or which is one of the top 10 restaurants in Berlin. So we are rather not curating the information, we are curating people who can decide if the information is true or not. And this is the business model which basically publishers do have, which we see companies do have, and a lot of other things. So you cannot build everything, every single possible company on top of those virtual companies we will offer, but just a subset of those companies, but this is still a lot. And this is what we're aiming at. And as you see, you need KILT Stage 1 to produce KILT Stage 2.
And is that an example? Like, so a regulated company would be on top of KILT, and then they could say, okay, we have this list of people or this list of other companies who are qualified to curate these lists, or would this be in the KILT level protocol?
It will be in the KILT level protocol. We will implement the TCR part. So the curation part, the curators are those who hold the tokens of the TCR and who have the voting rights. So the voting rights will be used to curate the experts, so the people who actually do the work. And this will be completely implemented in KILT.
But if you're talking about having many different applications built on KILT, who's in this list?
Anybody can start a TCR.
Right. Okay.
So it's just another JavaScript call, make TCR, and you have to give a lot of parameters, and then KILT produces a TCR in the runtime.
Okay, I was a little bit. I thought you meant there was one TCR in KILT that's.
No, definitely no. There will be hundreds.
It's more factory.
It's a factory for TCRs.
Okay.
So there will be hundreds of TCRs. So anybody can come and build a TCR. And give certain parameters. So then, of course, you can also build a TCR which is just a normal TCR, which is not linked to a text number and stuff like that. But then you're not in a regulated environment, and this is what companies probably don't want.
Yeah, so this is like a regulatory foundation almost. So you said KILT has been audited or approved in some way by regulators, and then you can build your own application and have a tax number linked to your TCR in the protocol.
But the application is then not programmed, it's just configured. And this is what makes the difference, because a regulator can check a configuration, but they cannot check the software.
Right.
This is where the big difference comes in. So if I have only 20 parameters, I can, as a regulator, check them and check, okay, is anybody who wants to invest required to have a KYC AML, and this is checked yes, then it's probably more probable that you get the text number than if you don't do that.
Sure, but this is, since your protocol is kind of open, you could decide to make a TCR without anything around it, just however you want.
Yeah.
And then how does geography play into this? Are you like regulated in Germany, in Europe, or do you plan to get approval from multiple different jurisdictions so that people can build on it?
Well, basically, we're a protocol, and a protocol gets approval where it gets the protocol. We're very closely working together with the German government. We are in Germany. We are a German entity, and and we work with the politicians for 1.5 years now, and we think that we are on a very good way to get things regulated in a positive way, not in a strict but positive way in this country, of course this system is completely open to other jurisdictions, and we have talked to people from other jurisdictions as well, and there's some interest because jurisdictions obviously notice that the whole virtual company thing is the next step. Well, right now we are in the phase where everybody's tokenizing assets, you might have noticed. And when the regulators are ready to tokenize assets, they have understood that there can be value actually put on a blockchain. And the next step, which comes after that, is that people will ask, okay, how can I virtualize a company? Basically, so if I can virtualize the shares of a company, why can't I virtualize the whole company? And when we go to this step, then it becomes very interesting for jurisdictions actually, because this is a part where there was a new tax inflow into a jurisdiction, because companies will be there and those companies will be willing to pay tax. So jurisdictions are actually very much interested in getting in talks with us there, because this will be, I think, a whole new kind of economy which is popping up there. And the first mover will probably have the most companies. So this is why everybody's really interested in that.
Sure. And so you guys have a testnet now. Where do you see yourselves on your road to KILT version 1, and then how long do you think? I know forecasts are always kind of 1 to 20 years type of thing, but
something like that. Yeah. Actually, I think we shouldn't answer that, because we will start a private sale in a couple of weeks, and I think the legal people wouldn't allow us to answer that question.
Fair enough.
I can just say, I mean, what we have right now is it's fully functional what we imagined about the claiming, attestations, verification process, sending messages, encrypting them, all the signatures, the schema. and 3 different methods of generating trust. And this can be already used. And yeah.
Yeah, I was going to ask where people can get your information and follow you.
Yeah, go to kilt.io, github.com/KILT Protocol.
That's KILT.
Yes, and KILT Protocol together. Yeah, and there you can see on GitHub we have the SDK, the demo client, everything launched. And on kilt.io you get the domains for our telemetry, our Chain Explorer, our demo client, yeah, everything you need.
All right, great. Go check it out. Ingo and Timo, thank you for coming in.
Thank you for having us.
Yeah, thanks. Bye-bye.
Thanks for listening to Relay Chain. We'd love to keep in touch. Follow us on Twitter @RelayChain or email podcast@parity.io. Our team at Parity includes some of the leading peer-to-peer networking developers, consensus algorithm inventors, blockchain innovators, and Rust developers. If you want to learn more about our work or want to work with us, visit our website at parity.io and sign up for our newsletter at parity.io/